All right, fifth grade. Today's lesson, we're going to finish the chapter review for math. So make sure you have your packet out. We're going to do 10 through 18, and make sure you have your graph paper from last lesson because we're going to need it for some of these problems. So 10 says, a shipping crate holds 20 shoe boxes. The dimensions of the shoe boxes are 6 inches by 4 inches by 12 inches. For numbers 10a through 10b, select true or false. All right, so I'm going to get my handy dandy pencil, and let's do number 10. So 10A asks, each shoebox has a volume of 22 cubic inches. A shipping crate holds 20 shoeboxes. The dimensions of a shoebox are, so the volume equals 6 times 4 times 12. So I'm going to do this as 6 times 48. Eight times 6 is 48. 24 plus 4 is 28. So the volume, this is of the shoebox, 288 inches cubed. Now, the crate can hold 20 shoe boxes. So that means that if one shoe box is 288 inches cubed and there's 20, we can find the volume of the crate. So this is volume of the crate. So we have 288 inches cubed times 20, putting my 0 on the side so I can just drop it down at the end. 2 times 8 is 16, plus 1 more is 17, and that's 5. Bring down my 0. So the crate is 5,760 inches cubed. So we can go through and answer our questions. Just need to find my pen here. All right, so let's do stuff like that so you can still see our work. Each shoebox has a volume of 22 cubic inches. No, it's completely wrong. Each crate has a volume of about 440 cubic inches. That's completely wrong. If the crate can hold 27 shoe boxes, the volume of the crate would be 7,776. Okay, so we just gotta redo the volume now. So now we're gonna do the volume of one shoebox was 228, and there's 27 shoeboxes. So this is for C. So we have 288 inches cubed, and we're going to times that by 27 shoes. So 8 times 7 is 56. 56 plus 5 is 61. That's 14 plus 6 is 20. 0 placeholder. Cross off what I canceled. Times that by 2. This is 16. 1 more. That's 17. And that's 5. So we have 6, 7, 7, 7. 7,776 inches cubed is the volume, and that is correct. So C is yes. All right, so let's go to 11. Mario is making a diagram that shows the relationship between different kinds of quadrilaterals. In the diagram, each quadrilateral on a lower level can be described as quadrilaterals above it on higher levels. Complete the chart. I'd like to go through my notes because I have this exact chart in my notes. Because there's an amazing fifth grade teacher who made me take notes. So I'm going to take out my math notebook, refer to my notes, and that was lesson 3 where we did the flow chart of the quadrilateral. So if we look here, we have quadrilaterals, and then from quadrilaterals we go to parallelogram. Yeah, triangle won't work. Trapezoid doesn't work because I want to get to square. So I know this is parallelogram. And then from parallelogram, I want to get to square. Well, rectangle isn't an option, so I know I could go from a parallelogram to a rhombus to get to a square. And now the explanation. Mario claims that a rhombus is sometimes a square. Well, a rhombus can't be a square because it doesn't have right angles or perpendicular sides. But a square is always a rhombus. Is he correct? Well, a square is always a rhombus because it has four congruent sides, but a rhombus is not, can't be considered a square. So let's put that in a nice explanation. Um, is he correct? I guess he's yes, because a square is always a rhombus. So if we only do yes or no, we're going to say yes. So we're going to say a square has four sides that are congruent and equal. So here's our explanation. Yes, a square has four sides that are congruent and equal. A square with these features is also a rhombus. However, when a rhombus does not have 90-degree angles, it is not a square. So it has to have those 90-degree angles because that's like the principle of the rectangle. All right, so that was number 11. Let's move on to number 12. Write the letter of the box that describes the three-dimensional figures. So remember polyhedrons. What's the difference between a prism and a pyramid, right? A pyramid, the lateral faces of a pyramid are triangles. All of the sides are triangle. The bases could be any polygon. A prism, the lateral faces of prisms are rectangles. Again, the base could be any shape, but the sides are all rectangles. All right, so that's the difference. So let's look at A. A has triangles on the sides, so that is a prism. B has rectangles, that is a, oh, look at what I did. A, B. I was just looking at the P, I didn't see that one. C has rectangle square, so that is a prism, and D is all triangles around. All right, Mark packed 1-inch cubes into the box with a volume of 120. So the volume of this equals 120 inches cubed. How many layers does he have? Well, let's first we can find the area, and then we can just divide and find how many layers that takes. So we have 1, 2, 3, 4, 5, 6, 7, 8. This is 8 by 1, 2, 3. 8 by 3. So 8 by 3 equals 24. So I could do 120 inches divided by 24. And I know that when I multiply by 4 by a 5, I can get a 0 in the ones place. So 24 times 5 is 20. 10 plus 2 is 120. So there are 5 layers. Right, using a little estimating there. All right, number 14, find the volume of this. So this is a composed figure, and we want to find this base, right? I'm going to say this is volume 1, and this is going to be volume 2. Remember, some of you had this problem on Think Central, and sometimes they asked you what was the area of the space taken away. We're going to do actually just the volume of all of it. I'm going to go to the back of my paper so I can have some extra space. All right, so this is number 14. Oh, you know what? Right here, this is part 2. Numbers 10 through 18. All right, number 14. Volume 1, length, width, height. So here's my figure. I'm going to say this is my length, this is the width, and this is the height. So 10 times 6 times 4. volume 1. Let's see if I can work like this so we can see it and still see the shape. Volume 2 equals length times width times height. So volume 2, my length is 4. My width is the same, so this is still 6, and the height is 3. So 4 times 6 times 3 equals 12 times 6. Volume 2 equals, sorry, 72 centimeters cubed. So now I'm going to take volume 1 plus volume 2 to get my volume. So 240 plus 72. So 312 cubic centimeters. All right, so let's go to number 15. All right, so this is going to go back to our flow chart. A blank is always a parallelogram. A blank is always a rhombus. A blank is never a parallelogram. All right, so I'm going to go back to my flow chart here on my quadrilaterals, which was lesson 3. So I have square, trapezoid, and rectangle. Well, I know that a square and a rectangle are always parallelograms. So that means a trapezoid is never a parallelogram because a parallelogram has opposite sides parallel and a trapezoid only has one parallel sides. So I'm just going to jump to C and know that a trapezoid is never a parallelogram. A blank is always a rhombus. Well, we know that a square is always a rhombus because we know a rectangle can't be a rhombus. So a square is always a rhombus, and then a rectangle is always a parallelogram that has two sides of parallel lines. All right, number 16 is kind of like a guess and check question, but what we need to do is go through each of those volumes or each of those dimensions and see if they equal 4,320. And it says mark all that apply, which means you'll probably even have two answers here. So I'm going to start with number 16A. And I have 16 times 16 times 18. So 16 times 16, 36, 96. Oops, that's 2. So, and then 256 times 18. 48, 44, 20. 4,608 inches cubed. So A, that does not match the answer, so it's not A. Let's go to 16B. And we have 12 times, oh wait, no, whoops. I was looking at C. 12, or 16B is 14 by 18 times 20. So 14 times 18, 32, 8, 9, 10, 11. $252, so 252 times 20 times 2 is 5,040 inches cubed. So that one's a no. I guess C and D are probably going to be the answers. But we need to show your work to get credit. 12 times 15 times 24. Minus 12, that's 13. So this volume equals 4,320 inches cubed. So yes, C is the answer. And 16D is 8 by 20 by 27. 27 times 20. 540 times 8. Yep, that checks out too. So C and D are the correct answers. So it's not really guess and checking. You just got to check all the dimensions and work them out. 17. Ken keeps paper clips in a box that is the shape of a cube, right? So what do I know about a cube? All the sides are the same. Each side of the cube is 3 inches. What is the volume of the cube? All right, well, volume equals length times width times height. So this volume equals 3 cubed. So that, what does 3 cubed mean? 3 times 3 times 3, which is 9 times 3, which equals 27 cubic inches. All right, Monica used 1-inch cubes to make a rectangular prism. Oh, already down to number 18. We're done. Yay, last problem. Write the value. Each value can be used more than once. Okay, so each cube has a volume 1 inch. Well, 1 times 1 times 1 is 1. So the volume of each cube is 1. Each layer of the prism is made up of 4 times 5, length times width each layer, so that's 20. There are 3 layers, so the volume of this prism is 60 cubic inches. That's it. Oh my gosh, that's the simplest problem. Okay, that's it. Wow. So really 16A wants you to practice your, or 16A through D, practice your double digit multiplication. All right, so you're gonna do Think Central Part 2, and then be ready for your, make sure you have this completed. And if you want to use your graph paper also for Think Central, just use any remaining space. Just make sure you label Think Central portion of your paper. And make sure you staple this, put your name on it. If you don't have a staple, just fold it for now and staple it when you get to class and put it in your folder. And we'll use it tomorrow for our chapter test. All right, bye, 5th grade.